It's time for the most challenging part of our project, but as per usual, I've tried to keep things as simple as possible because the fun is in getting results, not in learning algorithms. We're going to add collision detection to our code, so players can carve chunks out of the buildings, or, better, blow up their opponents. You will, as always, need to start by assigning self to be the delegate of the scene's physics world, so you can get notified of collisions. So, we will go ahead and make our game scene conform to the class skPhysicsContactDelegate. Then, in didMoveToView, I'll say our physics world dot contact delegate equals self, like that. Now, when it comes to implementing the didBegin method, there are various possible contacts we need to consider. Banana hit building, building hit banana, banana hit player 1 hit banana hit player 2, and player 2 hit banana. This is a lot to check, so we're going to eliminate half of them immediately by eliminating whether banana hit building or building hit banana. First, look again at the way we have our category bit masks up here. They're ordered numerically and alphabetically. Banana comes first, then building, and then player, and 1, 2, and then 4. So what we're going to do is create two new variables of type skPhysicsBody and assign one object from the collision to each. The first physics body will contain the lowest of these numbers, and the second the highest. So if we get banana, which is collision type 1, and building, collision type 2, we'll put banana in body 1 and building in body 2. But if we get building first, collision type 2, and banana second, collision type 1, then we'll still put banana in body 1 and building in body 2. And once we have eliminated half the checks, we're going to optionally unwrap both the bodies. They're optional because they might be nil, and this is actually highly likely in our project. The reason it's likely is because we might get banana hit building and building hit banana one after the other, but when either one of these happens, we'll destroy the banana, so the second one will definitely be nil. If the banana hit the player, we're going to call a new method called destroyPlayer. If the banana hit a building, we'll call a different method called banana hit building. But we'll also pass in the contact point. This tells us where on the screen the impact actually happened, and it's important because we're going to destroy the building at that point. We haven't written banana hit building or destroy player just yet, but we'll do it soon enough, don't worry. Let's go ahead and write didBegin now. Let's find some space way down here below deg to rad and say func didBegin contact. And first, we want to figure out which body got hit first. So we'll say let first body is some kind of skPhysicsBody. Let second body is some kind of skPhysicsBody. And now we'll do that comparison on our category bit mask. We'll say if contact.bodyA.category bit mask is less than contact.bodyB.category bit mask, then we'll assign the first body to be contact.bodyA and the second body to be contact.bodyB. But if it's the other way around, if body B has a higher number than body A, we'll do the opposite thing. I'll copy and paste that code in there and we'll say first body equals contact body B and second body is contact.body A. So it's the opposite here of the other case if it is less than. Next, we're going to grab the first node and second node from those two physics bodies. But if either of them is nil, we'll bail out immediately. It means we've already handled this collision. So we can say guard let first node equals first body.node else return. And then guard let second node equals second body.node else return. So only if we have both nodes in place will we actually continue with the collision detection. Next, we'll call those two methods we haven't written yet, banana hit building and destroy player, depending on what the first node and second node were. So we can say, if the first node has the name banana and the second node has the name building, we'll call this new method, which is banana hit some building, our second node, at the point contact.contactPoint, where the collision actually happened. if the first node name is banana and the second node dot name is player1, then we'll call destroy player1. Again, we haven't written destroy method yet, but that's okay. And then we'll do the same thing for player2. So if first node name is banana and second node name is player2, we will destroy player2 like that. Again, we've not written banana hit building or destroy player just yet, so you can ignore these Xcode errors. Let's start with destroy player. This will create a particle node with a little explosion, position it over the player, and then destroy both the player and the banana. But after that's happened, we want to give the player something new to play, because it means one of the players has lost the game, or at least one's won the game. So what we're going to do is create a new game scene with a new random buildings and 2 new monkeys to work with, and let the players play again and again and again. And helpfully, SpriteKit has a super stylish and built-in way of letting us transition between scenes. This means you can have one scene for your menu, one for your options, one for your games, and so on, then transition between them as if they were view controllers in a navigation controller. Let's go ahead and try that out now. I'll make a new method, which is called funcDestroyPlayer, an SK sprite node. First, we'll make sure we have an explosion, which we should do because we have hitPlay SKS up here we added earlier. We'll say if let explosion equals an SK emitter node with the file named hitPlayer. Awesome, we will do explosion.position equals player.position and add that to our game scene, like that. Next, we'll remove both the player and the banana from the game scene. So we can say that player dot remove from parent and our banana dot remove from parent. Get them both out of the game scene, they're both no longer needed. And now for the new stuff. After some period of time, 1 or 2 seconds, we want to show a new game scene. We want to go from the current scene to a new scene. And to do this, we'll make a new instance of our game scene class at the current size. We'll pass on our view controller property to be the view controller of the new game scene. And of course, do the opposite in return for the view controller. We'll make its current game property equal to our new game scene. We need to change players. That way it makes sure the other player gets a first shot in the next game. And then we'll do our transition between scenes. We'll go from our current game scene to the new game scene with an animation. First, changing players. This requires a new method. So I'll say down here, func change player. And all we'll do is say if current player is 1, then current player is 2. Else current player is 1. And then we can call on our view controller activate player with that current player number. So it will show the correct player 1 name or player 2 name in our UI kit layout. Okay, let's continue with destroy. So we've got these 2 removed from parents here. We're now going to say dispatch queue.main.async after. Deadline, I'll say .now plus 2 seconds. And for the closure to run, I'm not going to do weak self in here. We want a strong self. This thing won't be kept for ever and ever and ever. There's no reference cycle here. We do have to have self strongly at this point. So I'll say let new game equals game scene at the size of self.size. And that strong self is why we've got to have that right here, so we know the size of our current self. We'll say new game.viewController equals our view controller. And our self view controller has a current game property of the new game scene we just made. So this means the new game scene points to our view controller and our view controller points to the new game scene. So they can talk to each other nicely. We'll then say change player on self and then assign that to the current player property of the new game scene. So we can make sure the second player takes over if the first player just won or vice versa. And finally, the new part. We want to transition from the current scene to the new scene. And this is done using a dedicated class called skTransition. It has a number of animations built in. Let's try them out now. We can say let transition equals skTransition dot. And there are a few options here: crossfade, doors close, fade, flip, push, reveal, and so forth. I'm going to go for doorway, like that, with duration 1.5 seconds. And then say self.view.presentScene, our new game scene, with the transition we just made. Transition like that. And that will end the game correctly and show a new game scene after 2 seconds. Now it's time for the real work. How do we allow our exploding bananas to create holes in buildings? Surprisingly, it's not that hard. I'm going to split it into 2 parts. First is the banana hit building method. This will handle the explosion, delete the banana, and change players. Plus we'll add a hit at building node method that handles damaging the building. The first one, banana hit building, is easy enough. So let's start with that. So we'll say func banana hit building and sk node at point contact point CG point, which is the location where the banana hit the building. That one there, the contact point. That should in theory clear up the compile errors from earlier on because we now have banana hit building defined correctly. The first thing we're going to do is figure out whether we had an actual building passed in. Is this thing a building? Because you can see it's actually an sk node that's been passed in. Now, of course, we know that our check says pretty explicitly, if second node is a building, then pass that into banana hit. So we know it's a building. We could very safely do some forced typecast here, but there's no reason to. A much cleaner solution is to say something like this, guard let building equals building as question mark building node, else return. So at this point on line 178, we know we have a building node because this test here, this passed. Once we have that, we want to figure out where the collision happened. Now this contact point being passed in, that tells us where in our game scene the collision happened, in the whole game scene. But we don't care about that. We care where on this building was hit, which part of the building was hit. So we can go ahead and destroy that part of the building. To do that, we want to convert that point into the coordinate space of our building node by saying let building location equals convert our contact point to the building node. So tell us where that point is relative to this building rather than the whole game scene. And once we have that, we'll call a new method we haven't written yet called hit at. Tell the building we've been hit at this location, and the building can then go ahead and destroy itself there. So we'll say building.hit at building location. And again, we haven't written that yet, we'll do it in a second. And that will tell the building, go ahead and update your texture by destroying this part of the building. We'll come back to that in a minute. First though, we'll finish banana hit building. We're going to say if let explosion equals an sk emitter node using file named hit building, then explosion.position equals that contact point where the building was hit. And add that child to the game scene. We can then say banana.name is an empty string, banana.remove from parent, and banana equals nil. Now these two, as you know, they destroy the banana. But we're also going to set banana name to be an empty string. This will fix a small but annoying bug. If banana just so happens to hit 2 buildings at the same time, if it lands just next at the corner of 2 buildings, then it'll explode twice and thus call change player twice, effectively giving the player another throw. But here on line 186, I'm clearing the banana's name as soon as we've processed the first collision. And this means the second collision will never happen because our didBegin method won't see the banana as being a banana anymore. Its name is gone. And now for the part where we handle destroying chunks of the building. With your current knowledge of core graphics, this is something you can do with only one new skill: blend modes. When you draw anything to a core graphics context, you can set how it should be drawn. For example, should it be drawn normally? Or should it add to what's there to make a combination? Core graphics has got quite a few blend modes that might look similar, but we're going to use one called .clear, which means delete what's there already. When combined with the fact that we already have a property called current image in our building node, you might be able to see how our destructible terrain technique will work. Let's go to building node now. So you can see when we're creating our building, we call drawBuilding, which renders a UI image and stashes it away in the current image property and uses that for the texture of our building. When we want to destroy part of that building, we'll draw that image into a new context, draw an ellipse using .clear to blast a hole in it, then save that back to our current image property and update the sprite's texture. So we're going to write the hit@at method now. Let's start. We'll say func hit at point a CG point. And that'll tell us where the building was hit. But keep in mind, SpriteKit positions things from the center and core graphics from the bottom left. So we've got to do a bit of mathematics to figure out where the core graphics location of our drawing has to happen. So first we'll say, let converted point equals a CG point, with the x coordinate being that point has x value plus our size.width halved. And for the y value, we'll invert it because we've got to go from the other way around. It's the bottom left. So we'll say our abs will be our point.y minus size.height divided by 2, like that. And this abs function is new. It means take any negative sign and ignore it. Make it positive. So all numbers are positive. And that'll tell us where in core graphics space the banana hit in our image. So now you can render a new image with that gap in place. We can say let renderer equals a new UI graphics image renderer using the size of our size. Then let img equals renderer.image with the context coming in. First we'll draw our current image. Draw at .0. Fill the current image right in there so it looks like the existing building we have right now. But now we're going to add an ellipse over the collision point so we can clear it out and destroy whatever's there. Now in my testing I found ellipses of about 64 points look good. So we're going to say this kind of code. ctx.cgcontext.add ellipse in a CG rect with the x value of being our converted point where we hit .x minus 32, so 32 points to the left. And then for y, we'll do converted point .y again minus 32. For our width and height, we'll do 64 and 64, which means the ellipse we centered on the hit point exactly. The explosion will go around it, 32 points away and 64 points wide and high. Now for the important part. We'll say ctx.cgcontext.setBlendMode. I'm going to use .clear, destroy whatever's there already. And now when we say ctx.cgcontext.drawPath, I'm going to pass in .fill. When we say that, what we're saying is clear that texture space in the ellipse we specified. And now after that closure, we can assign that back to an SK texture using image img. Assign that to our current image texture, so next time we hit a collision, it'll be updated. And then, importantly, call configure physics again to redraw the physics around the new texture. And that's it for destructible terrain. There is one curious quirk of SpriteKit's physics, which is if you slice a building in two with lots of bananas, only one half will respond to physics, because it won't allow two physics bodies in one. Fortunately, the chances of that happening are pretty slim unless you're an appalling shot. There are just two more things to do with the game before we're finished. What if the banana misses the other player and misses all the other buildings? If you put in like a 45-degree angle and full velocity, chances are it'll shoot right off the screen, at which point the game won't end. We're going to fix this by using the update method in our game scene over here. So we'll say update at the current time. First, make sure we have a banana. We'll say guard banana is not equal to nil, else return. And then if abs banana.position.y is greater than 1000, then banana.remove from parent, banana equals nil, and change player. Now again, this abs function means remove any minus sign if there is one. Make all numbers positive. And so if the banana is minus 1,000 or greater than 1,000, it'll always call the same code. And so whether or not the banana's off the left edge or the right edge by more than 1,000 points, we don't care. It'll remove it from parent and change the player. So now we're calling change player if the banana goes off either end of the screen. But we also need to call change player inside banana hit. Because we've got to head this, clear the banana name, get it from out the game scene, destroy it entirely. But if the banana hits the building, it's time for the other player to play as well. So we'll say change player, like that. And with that, our game ought to be finished. I'll press Command R to try it out. Okay, so I'll press launch. Not bad. Nice instruction there. It's now player's 2 turn. You launch. Oh, yeah. Player 1 again. Look at that. We are chipping away at that poor building. I'm going to throw slightly harder. Let's do 160. Not 160. 160. Yeah! Ace. And a new game scene flies in. And it's now player 1's turn. Perfect. Let's throw. Oh, direct hit first time. I am obviously a genius at this game.